Hey, I wanted to wrap up section 3.4 and I needed to make a correction. So earlier in your notes where I wrote down second derivative test, that should actually be the test for concavity. I was just a little bit ahead of myself. That was a test for concavity where we said the second derivative of x was greater than 0. That meant it was concave up. And if the second derivative of x was less than 0, then that meant it was concave down, like a frown. Hallie. So that was all true. It's just called the test for concavity, not the second derivative test. The second derivative test actually says take the critical numbers from the first derivative. If the second derivative at those critical numbers is greater than 0, then f has a relative min. At that point c, that critical number c, comma f of c. And if the second derivative is less than 0, then f has a relative max. Hi. At c f of c. Okay. And if the second derivative of c equals 0, then the test fails. And we need to do the first derivative test to figure out mins and maxes. Now, at first glance, this might seem like, oh, that doesn't go together. That doesn't make nice sense, because if the second derivative at c is greater than 0, it's positive. But think about what that means with this test for concavity. If it's greater than 0, then it's concave up like a cup. And what happens right there? That's a relative min. So see, it does all go together. It's just, it takes a little more thought. So if it's greater than 0, it's concave up, which does have a relative min. If it's less than 0, it's concave down, which shows a relative max. So it goes together. Let's try one out and see how this works. My light went out. We're going to find the relative extrema. Using the second derivative test. So f of x equals negative 3x to the fifth plus 5x to the third. All right, let's find our first derivative. And let's find the second derivative. All right, let's take that first derivative. Let's set it equal to 0 to find our critical numbers. Let's factor out a negative 15x squared. I'm factoring the negative out because I don't like it when the leading coefficient is negative. Excuse me. Ugh. Set those factors equal to 0 to find those critical numbers. And then the second derivative test says plug them into the second derivative. So the second derivative of 0 is negative 60 times 0 cubed plus 30 times 0 squared. Well, that's 0. So the test fails. So I don't know what happened at 0. I have to do the first derivative test on that one. Let's plug in negative 1. That's negative 60 times the negative 1 cubed plus 30 times negative 1 squared. That's a positive and a positive, so it's positive. So that means we have a relative min at x equals negative 1. And last, we'll plug in the last critical number, which is 1. And it's going to have a negative answer. So that's a relative max at x equals 1. Okay, that's it.